So today's lesson is just a quick introduction or an overview of the string project. I think I'll use, the string project is definitely a review project, reviewing the string class that you are familiar with. It doesn't require for you to write a class. It just requires that you write methods and you become more familiar with the string, built-in string methods that are there, which shows up pretty often on the AP exam. Level 1, you're going to read into a string, so you'll use either scanner or you can use input dialog box. That's your choice. You read in a string, and you'll write a routine called echo that echoes the name back. So if we read in the name Tom, it'll be able to read it in and print it back if we call the routine echo. We'll write a routine called last first. So we have a routine called echo that we're going to write. We'll write another one called last first, and last first returns a string of in the format last name, comma, first. So if the name we were to type in there was Tom Shoe, it's going to print out Shoe, comma, Tom. So that's what last first will do. And we'll also write a routine called initials. So the routine called initials, if the string is Tom Shoe again, the routine called initials will return T period S period. So we're returning a string on each of these. We're not printing out a string, we're returning a string. And then the client program could decide to print them out or not. And you'll write a client program to test all these. So you're going to write the routine called echo, you're going to write the routine called last first, and the routine called initials. And in addition, you'll write a client program to read in a string and then call echo, call last first, call initials, and print out nice results for us to see that that's working. That's level 1. Level 2 is the same as level 1, but it would work with names like single names or multiple names, more names than 2, like, for instance, Madonna. So Madonna has only, if we do initials for Madonna, we're going to get just M. Or a name like John Jacob Jingleheimer Smith, we're going to get for our initials, we're going to get John Jacob Jingleheimer Smith. So it's just level 1 enhanced, and I called it level 1 plus. If you struggle with that level, skip it and come back to it. Do the levels that you have success with to start with. We're trying to become programmers, become confident, and build some confidence and have some success as we go. Level 2, write a routine called caps. It returns the string of the name with all caps, so the same string. So if the name we put in again was Tom Shoe, it will return the string Tom Shoe with all caps. Simple. We also want you to write another one that returns a string of all lowercase. So that one's self-explanatory. I won't spend any time on that. Level 3, write a routine called no spaces that returns a string without spaces. So if the name was Tom Shoe again, it will return Tom Shoe without a space. If the name is John Jacob Jingleheimer Smith, it will return that without a space. If we have a phrase that has spaces, we're going to crunch it down to have no spaces. Also, simple process, but it's going to take using some string manipulation to do that. You're going to have to look for a space. You look for a space, so we have Let's start out again here. Tom. Shoot, you're going to look to find the space. So you're going to make a substring of everything from the beginning up to and including the space. So you'll have Tom in your substring. You'll then look for beyond the space, and you'll look again for the next space. If there is no other space, it'll just be everything else will become a second substring that you will concatenate with the first one, and then return that concatenated string. Strings are immutable. That means you cannot change them. So you can't just take Tom's shoe and think you're going to be able to eliminate the space. You have to create another string that's just this substring, and another string that's just this substring that you concatenate to the first one. When you concatenate, that returns a new string. That new string in our example would be Tom's shoe, and that's what we would return. Level 4, write a routine called reverse that returns a string of the name reverse. So if the name were, again, Tom's shoe, the reverse name would be Mott. So again, you're going to need to do some string manipulation using the functionality that's built into the string class. I will do some further lessons on this, remedial lessons that you'll see later in the week that you'll be able to use if you're struggling with some of this stuff. But right now, I'm just introducing what you need to do, not so much how you need to do it. Level 5, write a routine called isPalindrome. So isPalindrome is going to check to see if, in fact, a name is a palindrome. So, for instance, the name Bob is a palindrome because it reads the same forwards and backwards. The name Otto is a palindrome. Too fat a foot is a palindrome. The phrase too fat a foot, you may think is not a palindrome because T-O-O, T-O-O, and then you have a space, and here it's T-O-O, and then here it's T-O-O, and then a space. Going backwards, it's T-O-O, and not the space. Well, palindromes, you eliminate the spaces before you check to see if it's a palindrome. So if you remember, we've already written in level, I don't know, maybe it was level 3, we wrote a routine to eliminate spaces. You can use that in trying to see if you have a palindrome. The other thing that palindromes don't care about, they don't care about capitals or lowercase. So you can get rid of capitals or make everything capital or make everything lowercase. We wrote that already. That's actually built into the string functionality of the string class. And then we wrote a reverse. We could reverse, then we could see if the strings are equal. How do you check for strings are equal? If you have string 1 and you have another string called string 2, this does not check to see if string 1 equals string 2. This checks to see if they're the exact same object. You have to do S1 dot equals, you may recall. That may return a true or a false. And that's all I'll say about that one. Level 6, write a routine called crunch that returns a string of input and crunch down to a string that contains no spaces and no vowels. So, for instance, suppose my phrase was cool, fast car. If I got rid of all the spaces and all the vowels, it'll be cool, or CL, FST, CR. This might be my license plate. Anyway, we want to write that routine crunch. It looks for spaces and eliminates them. It looks for vowels. No vowels and no spaces. That leads us to Level 7. Write a routine called vanity plates. Returns a string that crunches the input down to 8 characters or less. New York State license plates can only have 8 characters. Don't spend too much time thinking about how to do this so that it still retains the flavor of the original input. My suggestion is, or I'm not going to accept it as being complete, if you just eliminate the first 4 characters, or the first 5 characters, or the last 12 characters, so that it shrinks down to 8 characters. But you need to do some type of algorithm that you come up with. You're going to get rid of spaces, you're going to get rid of maybe vowels, maybe that's a good idea. See if it's still greater than 8. If it is, you need to shrink it down so it's just 8. Like that guy with his cool, fast car. 1, 2, 3, 4, 5, 6, 7. He's good. If you eliminate spaces and vowels and he shrinks down to like 3 or 4, that's not good. You could have given him a bigger license plate. You could have given him more for his money. And the last one is to write a routine called dashes. It returns a string made up of dashes and spaces in place of the original chars and spaces. So this one I think is self-explanatory. What it looks like, it's basically the beginning of writing a hangman program. If we want to write a hangman program, we need to be able to put up the clue and say it's a phrase or a movie or whatever, but we're not writing a hangman program yet. All we're doing is taking the string and returning dashes for all the letters other than the spaces. We're going to leave spaces. So dashes for the letters, spaces for the spaces. I'll follow this up with some lessons showing you how I did some of this later on as a remedial lesson for anybody who needs it or is struggling. Good luck with the project.